In this example, we are introduced to weighted graphs. I'm just going to write it up here. And a weighted graph is a complete graph that has numerical values associated with the edges of the graph that are called weights. These weights typically represent distances, money, time, or some other type of capacity. It all depends upon the relationship between the vertices that is being determined. So here we are going to be using the brute force method, here it is right here, to answer this scenario. So it says, suppose the sales director to a company has to visit representatives across the country. Leaving the company headquarters in Houston, Texas, the sales director must fly to Fargo, North Dakota, Tampa, Florida, and Raleigh, North Carolina before returning. Airfares between the cities are listed in the table, and here's the table here. If the company wants to keep the total airfare to a minimum, determine the cheapest route the director should take. So before we get started, here's a couple of things I'd like to point out. That the sales director is going to be leaving Houston, Texas, and then returning. So obviously it's going to be a circuit. And then of course he's got to go to these 4 cities. And the object here is we want to determine the cheapest route. So we want to keep the cost, the total cost of the airfare to a minimum. So the first thing we need to do is create a graph that represents the traveling that the director has to do. So he's going to be going from Houston and then traveling to Fargo, Raleigh, and Tampa. So how about if we do something like this? And the graph doesn't have to be anything fancy. Keep it simple. Typically, if I have 4 vertices, that's what the vertices are going to represent, the destinations. Those are going to be the cities. Since I have 4, I'm just going to keep it very rectangular. And this is a complete graph, so every vertex connects to every other vertex. So how about if I make this Houston, Fargo, Tampa, and then Raleigh. So he can fly from Houston to Tampa. Certainly fly from Houston to Raleigh. Houston to Fargo. You can fly from Fargo to Tampa or vice versa. So I think you get the idea. So here is our complete graph. Now the weights are going to be attached to each edge here, and those weights represent the airfare between those cities. So between Houston and Tampa, so here's Houston here, here's Tampa here, so that's $280. So I'm just going to pen it in right here. It's going to cost $280. That's the airfare between Houston and Tampa. Between Houston and Fargo, that's this edge right here. Houston and Fargo, that's $300. And we just label each edge according to what the table says here. Between Houston and Raleigh, so Houston and Raleigh, that's $190. Between Fargo and Tampa, that's this edge here. Here's Fargo. Here's Tampa, that's $325. Between Tampa and Raleigh, here's Tampa, here's Raleigh. Or you could do Raleigh and Tampa, it should be the same. That's $295. And this edge here from Fargo to Raleigh, here's Fargo. Here's Raleigh, that's $310. Now the number of possible circuits, possible routes that the sales director can take, well, we have 1, 2, 3, 4 vertices. So we have 4 vertices, and there are n minus 1 factorial possible circuits that the director can take. So this comes out to be 4 minus 1 factorial. That's 3 factorial. And 3 factorial is 3 times 2 times 1. 3 times 2 times 1 is 6. So there are 6 possible routes that the sales director can take. And of course, what they're trying to do is figure out the cheapest one. So what the brute force method says, it says list all those routes, and then we're just going to tally up the edges between those vertices and determine which one's the cheapest. So we can go from Houston to Tampa. So I'm going to go Houston to Tampa. Then the director can fly from Tampa to Raleigh, then from Raleigh to Fargo, then Fargo back to Houston. So from Houston to Tampa, that's $280. From Tampa to Raleigh, that's $295, and we just tally up those amounts. From Raleigh to Fargo, that's $310. And from Fargo back home to Houston, $300. Add all this up, and it comes out to be $1,185. So if this was the particular route that the sales director decided to take, fly from Houston to Tampa, Tampa to Raleigh, Raleigh to Fargo, Fargo back home, it would cost $1,185. We have 5 more circuits, 5 more routes that we want to determine. And all we're going to do is do the same thing that we did here, tally up the total cost and see which one's the cheapest. And that should be the route that the director should take. So another particular route is he could go from Houston to Tampa, Tampa to Fargo, Fargo back to Raleigh, and then from Raleigh back home to Houston. And we do the same thing. Houston to Tampa, $280. Tampa to Fargo, right? We're going from Tampa to Fargo, $325. Fargo to Raleigh, $310. Then Raleigh back to the headquarters in Houston, $190. Tally all this up. That comes out to $1,005. So it's cheaper. We found a cheaper route. $80 cheaper. So we're going to do that for the other 4. We're going to do that for the rest of them. So as we look at our results, we have this one right here, $1,105, and this one right here, which is the same. And you can notice that we have $1,185 here, and we also have $1,185 here. That's because they're reverse orders of the circuits. Houston, Tampa, Fargo, Raleigh, back to Houston. This one here is Houston, Raleigh, Fargo, Tampa, back to Houston. So they're just reverse orders. So when you come up with the same amount for some of them, that's because the circuit's going in a different direction. But it's the same circuit. So if the sales director wanted to keep the cost to the minimum, then they would have to do the circuit that's either Houston to Tampa, Tampa to Fargo, Fargo to Raleigh, Raleigh back home to Houston, or fly in the reverse order, this one down here, and it would cost $1,105. Now, the brute force method is very straightforward and will always yield a definitive result, and that's because all the possibilities have been explored. They're all listed. However, this method is limited because as the number of destinations or vertices increases, the number of possible Hamilton circuits increases very rapidly. So, for example, rather than going to 4 cities, let's suppose he had to travel to 9 cities. So n is equal to 9. Then n minus 1 factorial. That's going to be 9 minus 1 factorial, which is 8 factorial. And 8 factorial, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 40,320 possible circuits that would need to be explored. Well, that just isn't practical, especially when you're just trying to save a few dollars as you're going out visiting these reps.